Hello, good morning, good afternoon, everybody, and welcome to the latest webinar from 42Crunch. We're just at a couple of minutes past the hour. I'm going to hand over to Colin, who will be your presenter for today. Colin.
Thanks very much, Hugh. Thanks to everybody taking the time out of their day to join today's webinar session, 1st of August. Today's topic is something old, something new. We're looking at the OWASP API Security Top 10 in 2023. The OWASP Foundation has updated recently from the 2019 version. We are now looking at the 2023 current version. We're going to look at the differences. So my name is Colin Domoney. If you're familiar with 42Crunch and you've joined previous webinars, you'll be familiar with my voice. I'm the Chief Technology Evangelist at 42Crunch. I come from a long background of doing DevSecOps and application security. And most importantly, in my role, I'm the editor of the API Security.io weekly newsletter, which is the #1 source in the industry for API security news. So as I said, I curate the weekly newsletter, API Security.io, and obviously from that, I get a lot of industry news from trends. So I've got my own opinions on what I think are, the emerging and the declining threats. And it's always interesting to see how that correlates to what the OWASP Foundation have decided on in their wisdom. We look briefly at their methodology of how they score and rank vulnerabilities. We look at the 2 items that drop off the top 10. A lot of items stay the same. That's why we call this something old, something new. There's a lot of familiar items. And then we take a deep dive into the 3 new items, which will be of most interest, and then time for Q&A. So let's get into the OWASP top 10. So firstly, my own research on API Security.io. If you don't subscribe to that, there's a link. You can go and grab a link and sign up to that. And that's a vendor neutral newsletter that we put out every week, where we look at emerging topics in the realm of API security. Almost every week, there's one or more vulnerability. And what I always do is I try and trace these back to the root cause. So which of the top 10 issues affected that? So as we go through this, I'm going to draw on some of that experience, some of the flaws that we've seen, and to understand those root causes. So firstly, how does the OWASP Foundations, if people aren't familiar with OWASP, it's the Open Worldwide Application Security Project. They have a number of working groups that focus on topics of interest, and they have a dedicated API security working group who publish the top 10 vulnerabilities. Now, the way they do this, it is an open forum. Anybody can participate on this. In this forum, you can go and join and register your interest. You can participate in the scoring methodology. They do this all by GitHub, by pull request. There's a lot of interesting discussion on how they've come up with their views on what that top 10 looks like. Now, the way they do this is they look at 3 categories. They score the vulnerabilities on a 1 to 3 scoring scale. And they look at topics like coming across that top bar, start with the exploitability. So if something is really easy to exploit, it scores high. It scores low if it's difficult. If the weaknesses are widely spread, it scores higher. If the weaknesses are easy to detect, it scores high. If the technical impact is high, it scores high. So obviously the more of those issues that you score on, the higher up that ranking you go. So there's a bit of science to how they do this. It's not it's not only personal opinion, but that's their methodology on how they rank the vulnerabilities. So if we stack up the 2019 version on the left versus the 2023 version on the right, we can take a look through that. So let's look at the deltas. Let's have a look what changed. So I'm highlighting the 2 categories. So we have API number 8 and API number 10, injection vulnerabilities and insufficient logging and monitoring vulnerabilities that drop off the top 10. Now, that doesn't mean that those categories no longer exist. And we'll see in a moment, injection attacks are still very, very prevalent. Some of the underlying thinking in the OWASP group was that they are focusing more on categories that are specific to API security, right? And in those 2 categories, there are ones in particular that apply to most software systems. So they favored new flaws or flaws that are API specific. So that's the underlying thinking. So those two drop off the top 10. That doesn't mean that you shouldn't pay very careful attention to them when implementing your APIs. Let's go and look at the large number of vulnerabilities that stay the same. So top of the list still is BOLA, broken object level authorization. And just for people to refresh what that is, that's when an attacker is able to modify an object identifier, so in other words, an object reference, and gain access to another object to which he shouldn't have access. Right, so this is something that is taking an ID parameter as an ID object as a parameter, and an attacker discovers that he can swap that on the fly and gain access to something that he doesn't own. All right, now going back to that OWASP scoring methodology, this is an easy one to exploit. It's quite easy to discover. It's quite prevalent. And of course, it's high impact. If you can suddenly access somebody else's data by just being able to switch object references, that's a significant impact. In fact, the biggest bug bounty that we've seen, certainly in my time editing the newsletter, $250,000 was awarded to somebody who identified a BOLA flaw on a trading platform, where he basically discovered that he could print money. He could just make infinite transactions with no funds. So BOLA, I think, justifiably staying at the top, and that's largely driven by its severity. The fact that if you get a case of BOLA, best case, you're leaking somebody else's information. Worst case, you're leaking everybody else's information, and it could be more than information. It could be transaction details and the like. The second category that stays the same, although it's changed name slightly, broken user authentication, stays number 2. It now gets renamed the more generic broken authentication. Obviously, APIs are human and machine driven, so the user drops out of that. For me, this is the number 1 vulnerability. Nearly every, and I have actually looked into this, nearly every vulnerability that I've covered has somewhere in it broken authentication. This is just something people just seem to get wrong. It's an easy one to get wrong. It's also an easy one to make sure that you don't get wrong. So it's that double-edged sword. You know, people do make mistakes with this, but it's one of those that's quite easy to correct and detect and correct. Then what OWASP did is they conflated the 2 data categories. So we got API 3, which was excessive data exposure. So this is when an API leaks more data than it should. And its counterpart, which is the mass assignment, which is when an API accepts more data than it should. So think of those as the read and write operations. And what OWASP have done is they've just put those 2 together and calling that broken object property level authorization. Lots of words. Just means reading and writing more data than you should. Another one that gets renamed is lack of resources and rate limiting. OWASP have given that a slightly more catch-all, broader term, and they've brought that out to resources. So this is not only about being able to access APIs and do too much with them, but it's also a nod to the adoption of GraphQL, where GraphQL with its compound and nested queries can really be quite resource intensive, and there are attack vectors on GraphQL implementations that, you know, obviously designed as denial of service attacks that can limit the or can exhaust the resources available on the server. One that stays exactly the same, number 5, broken function level authorization. So like we had number 1, we had broken object level, where the access controls to the object are broken. And this one, we've got access controls to the function are broken. So in BOLA, we can access somebody else's data. In BFLA, we're able to do something to somebody else's data. The canonical example there is a delete operation on something. We are able to retrieve an image via an API, and we discover that we can call the delete method on the same object, and it deletes the object, and we shouldn't have been able to do that. Also commonly where we discover there's an admin API endpoint, and we discover that as a normal user, we have access to that, right? So it's about being able to, BOLA is about being able to do things with data. BFLA is being able to do, to perform operations. Security misconfiguration, that one moved down one, which kind of messed up my table, but it's still there. Security misconfiguration. This is quite a broad catch-all. This is, you know, the various things that can go wrong on an API implementation on the server on the back end. So it's leaving unused methods enabled. It's leaving default endpoints that you don't use. It's broken access controls around the runtime of your server. It's excessive logging. It's any number of things that can go wrong with implementing your server itself. We've got improper assets management, which changes to a slightly broader term and a more, I think, just industry accepted term nowadays. That's improper inventory management. That's about knowing what APIs you have and what you don't have, and which of those are under your control. So it's all addressing the issue of shadow and zombie APIs. So now the three new ones. So we're in at number 6. We got a lot of words there. Unrestricted access to sensitive business flows. There's a very simple three-letter word for that, bot. That's your bot attacks. And this is where you expose business flows via APIs, and then an attacker or somebody just being a nuisance comes and discovers that they can do unusual things with your API and sort of use it against you. So there's not necessarily a vulnerability in your API as such, but some people discover that they can use it in unusual ways. And we'll look at some examples when we get to that in detail. This is a new one that's an old one. So if you've been doing AppSec for as long as I have, you know server-side request forgery and its counterpart CSRF, client-side request forgery. So what happens is in your API, you'll make a request. The server will, without checking the resource that's being requested. So in other words, you'll pass in a URL, which is a redirect. So think of something like a webhook, where you will be able to redirect to the webhook. Now the server blindly redirect. So it's an open redirect. And the problem with that is that the client can trick the server into going somewhere that it shouldn't. So it can do accesses to local hosts, to local file systems that it shouldn't be able to do. And this is obviously quite dangerous because you're really opening yourself up to the client being able to control whatever you do. So that's quite a severe one. We see this a lot in APIs now. This is becoming quite prevalent due to the way that microservices are architected and interconnect. They're often passing server references or references to file systems around and internally. And then the other one, and this is another one of these business ones where it's not so much a technical issue, but this is the unsafe consumption of APIs. We don't design API systems anymore. We really assemble them with a lot of building blocks. The APIs allow us to connect these building blocks together. And the problem is, if you're using an API, you're placing quite a lot of trust in that upstream API, right? And some of those APIs could be unsafe. Right. So in summary, 2 drop out. Many, I think 6 or 7 stay the same, and then we've got 3 new categories. So what we'll do now is I'm going to pop up the first poll question. So of those categories, which one of those 5, and there's one answer here, which one causes your organization the most amount of pain? Okay, so yeah, broken authentication, that makes sense to me. Broken object and broken function level also rated pretty highly. Yeah, interesting. So I'm with that. Broken authentication, I think, is the number one. Glad to see that. Well, I'm glad to see that, but you know, it does gel that the audience see that as well. So let's go to the 2 that dropped out. We can go over this quite quickly. So this is an interesting one. There was a lot of discussion. If you go and it's quite when you get the slides when we share them, go and have a look on the GitHub repo and have a look at some of the discussion around this. There was a lot of discussion that injection is still a very prevalent attack vector. As recently as issue 200 of the newsletter, September last year, we had it was Bitbucket that had an SQL injection vulnerability, And remember, it's not only SQL, it's command injection. It's command injection. There's other injection. Cross-site scripting counts as a injection attack. There's a lot of other attack vectors that happen with injection. It happens on any software system. It's also one of these that, despite how prevalent it is, it's one of the ones that's really, really quite easy to address. And there's a couple of patterns. The OWASP Foundation does fantastic work on this, on firstly validating your input and then using methods in the case of SQL injection, using database access methods that are immune to SQL injection based attacks. And 42 Crunch, we are also able to do this by being able to parse and filter your input data and understand if we see things that are looking like SQL injection, we can address those before they reach your API. But as I said, it's still relevant. Some good discussion on that one. Don't forget about injection. It's not only SQL; it comes in a variety of guises, and it's still prevalent anywhere we're using computers and we're taking input. We're going to have this problem. Insufficient logging and monitoring. The comment I normally make is we do logging and monitoring in two different ways. We either do not enough of it, where we don't capture the information that we need when we have a security incident, or we do too much of it, where we leak sensitive information, we leak credentials via our logs. There was a CI/CD system that had an API vulnerability. One of their main issues was that they stored all their credentials, all their tokens and everything in log files, which were accessible via the API and weren't masked or obfuscated at all. Right, so we do too little or too much. We don't record the right things. We don't surface the logging information in the right places. And it makes it hard to address vulnerabilities or breaches, at least when we have them. Now, I'm with this one dropping out of this. This applies to any software system. This should just be a standard thing that people know how to do, or at least know how to apply the patterns. Right, now the interesting bit of the webinar, we look at the three new ones. So as I said, API 6 2023 is unrestricted access to sensitive business flows or bots. Now this is another one. If I had a second choice, this would be my number 2 of most prevalent or most worrisome vulnerabilities. Right, we're seeing, well, let me explain what it is first. So typical examples here are ticket booking systems, shops that are offering online discounts, airline booking systems, anything that has a valuable asset attached to it, like a ticket for, we just had the Ashes cricket, right? If you wanted to go and try and buy tickets for that, almost impossible to do, even when they came online, they sell out. We're all familiar with that. You get put in a queuing system, you get booked a ticket. Same with airlines. The airlines offer summer discounts. People are able to go and reserve seats. They go and book the seat. And then the business logic is a little bit broken. And what the business logic does is it defers the point of transaction to be able to purchase the ticket. So you reserve the ticket. They give you 72 hours to purchase the ticket. So what people do is they go and apply a bot. To that, they go and reserve all of the seats. The airline thinks that they've sold the seats. And then what happens is they dump all the tickets online, and the airline suddenly realizes that its flight's on full, so they drop the prices and people go and buy the tickets, right? So there's no API vulnerability, but there's certainly a logic vulnerability. That's a business flaw that people haven't thought how clever, and bear in mind, when you're building something, there's always going to be somebody out there that's slightly more wily and clever than you are, and that's just how it is, right? People have got more time on their hands, and they will come up with clever ways to attack things, and that's a classic one. Ticket systems, anything that where there's where you can do those transactions and block book at bulk. And we're seeing a lot of this now. The Twitter exfiltration, that was really an unrestricted access to business flows. So the issue there was attackers were able to exfiltrate every user on Twitter their email address and phone number. And that was simply by abusing the login flow on the Android login flow, right? You know, the moment where you enter your, where it says, do you have an existing account? And it says, enter your email address. If you enter your email address, it comes back with your Twitter username. Now, for an individual user, that's no big deal. But of course, when people worked out they can automate that, when they submitted every known email address in the world and basically harvested every Twitter user ID, right? So being able to, it's API abuse, it's misuse. And this is a really big one. I think most weeks we see some or other instance of this. Now, let's look at the preventions. These are the OWASP recommendations. There's two approaches to this. One is business. So think of those business flows and how people could abuse them. And then engineering. So there are engineering things for the techies out here. So what can we do? We can do device fingerprinting. So make sure that we, you know, when I was trying to buy a house in the UK, I decided I'd scrape property data. Right, those websites are very impervious to scraping. Right, they can detect headless browsers. They can detect anything that doesn't look like an actual browser. They're very, very good at that. So fingerprint the devices and deny anything that doesn't look like a normal client device. Human detections or captures obviously don't work too well with APIs, but look for things like non-human patterns. So impossible, impossible movement, people being able to add multiple items to a shopping cart and click checkout all within a couple of milliseconds, right? That's not a user doing that. To do a lot of that, we can do things with rate limiting. We can do things with IP detection, IP reputation. These are all mitigations though, right? So your attacker will always be able to get around those. So this is a game of cat and mouse, right? It's how fast you can move. It's probably I would say it's now the most common attack vector. It's also easy for someone to go and start tinkering and messing around with APIs. It's always easy to be able to find out how the APIs work by just having a look at the website, put browser tools on, go and have a look what the APIs are doing, and then sit in with a Postman or with some Python code and go and automate that. Not that I'm recommending we do that, but that is what is happening. So how would 42 Crunch deal with that? So we have a Microfirewall, which is a firewall that sits between your clients and your backend implementation. What we're able to do is we're able to log all of your API traffic. So that's at layer 7 at the API level. So it's very precise data. So we know exactly what the requests are, what the requesting IP is, what resource that we're trying to access. And we log all of that. Now, our recommendation is to use the power of platforms like Microsoft Sentinel, right? Microsoft on the Azure platform probably have more sources of information of indicators of compromise or dangerous IP address ranges, right? They simply have one of the biggest target estates, and you can, if you're a Microsoft customer using Sentinel, you are able to harness that information and then correlate that with the traffic that you're seeing on your APIs, right? And then use that to write rules, being able to look for things like you could quite easily go and time how long individual API transactions are taking, right? If you see an add to basket and a checkout happening within, I don't know, a second, flag that, drop that transaction, right? Or at least identify that transaction. Right, so things that we can do on, we don't do it in the firewall itself, but we leverage the power of a platform. We've got 2 good webinars. We'll put the links in there where we show this working in practice. If you go onto the community, download the plugin, there's already templates for analytics rules for, I think, 12 different common API attacks. Server-side request forgery, we got a great webinar we did with Jim Manico. If you could also grab that link, please, Hugh. That's worth watching in its own right, not least of all for Jim's expertise on client-side and server-side request forgery. And just a reminder here, SSRF is when a client, which could be obviously a malicious client, can trick your server into redirecting somewhere it shouldn't. Okay, what are there's a long list. You can imagine what the list, let's have a look at that. That list of prevention mechanisms. This is pretty much all about validating that input. So what do we have there? We have the second to last: validate and sanitize all clients supplied input data. That's a general good practice for anything where you take in client data in. Validate it, sanitize it, don't trust it. Disable open redirects. What else do we do? If you're parsing a URL, make sure that you're using a library that's well validated and has been well tested. Don't try and write your own, with all due respect, at least. People make mistakes. URL path validation is quite a difficult thing to do. There's lots of ways those can be defeated. So use something that's hardened. Use the OWASP recommendations. And filter and restrict that. And then where possible, use an allow list, so that only allow access to specific resources of which you're certain you have control. So that's server-side request forgery. Again, how does 42 Crunch help with that? It comes back to that point of input sanitization and validation on your API. If you've defined your data, and you should, within your open API definition, we can enforce that at runtime in your firewall. Right, there's things that we can do, like we could restrict paths that are being accessed to a specific known path, rather than allowing people to be able to modify and inject that at runtime. Okay, so then the final of the new categories, this is unsafe consumption of APIs, and this is one that is really interested to see come into this. So I think if we're in the software security industry, we've seen the interest that is arisen around supply chain security, right? I refer to my previous comment about the fact that software isn't so much built anymore as assembled. It's a long list of components that are being connected together via APIs. Now, unsafe consumption of API talks to the point where if we have upstream APIs that we are consuming, so we have something that is doing, I don't know, let's say it's giving us a feed of traffic information or something going into our system. Developers have an intrinsic trust in systems. They tend to trust. The reason that we have problems with injection attacks is because developers are inclined to trust external input. And they're even more likely to do that if they're consuming that via an API. There's some implicit assumption that because it's coming from an API, it must be safe. That's certainly not the case. What happens if there's a vulnerability in your upstream API provider? And then, heaven forbid, what if there was malicious intent on the part of your upstream provider? What if somebody was able to typo squat the URL of the API and redirect you somewhere else? How much trust are you putting in your upstream APIs, right? So consider your APIs as part of your supply chain, and they need to be secured at every point. OWASP make a number of pretty good recommendations here. So that one about talking to the point of your network access. So really harden your connectivity between your upstream APIs. Your threat vector. Think about when you're doing your threat modeling, think about how could an attacker connect to something, force you to connect to something that is not what you think it is. So make sure you're using neutral TLS, you're doing certificate authentication on that. It's going over a secure channel, and that you're able to fully verify that connection through whatever means is appropriate. Sanitize and properly validate and sanitize that input. Again, that you should be doing that at all points. Never trust that data. So the top one there is also important. So when you're consuming APIs, always think about the security provenance. Think about, do you trust the APIs that you're consuming? And if you do, what is that trust based upon, right? Because you may be making some unsafe assumptions there. So always think about, not only from the technical point of view, from the connectivity and validation point of view, but think of your commercial arrangements that you have with your upstream suppliers. Do they guarantee you? Do they make any statements of the integrity of the service that they're providing? Right? They might be offering you quality of service conditions, But are they making any statements as to, the validity of the data or in the integrity of that data? And the way we deal with this, so I'm running Acme Corporation, which is consuming upstream APIs from the rather creatively named X Corporation, hypothetical name, X Corporation, which is providing a number of APIs. So on the left-hand side there, I'm blindly consuming that API. So you can see it's obvious there. I've opened myself up to a lot of risk there, right? If that corporation were to do something nefarious with that API, they've got a direct line into my systems. Now, the way we can address this 42 Crunch, we've got a very elegant solution to that, and that's to use that firewall that we have, which is normally used as a reverse proxy mode for inbound connections to an API. We can use that as a forward proxy to validate. So in that firewall, we could specify exactly what that API one is supposed to do in its contract, and hopefully we have a contract because we would have an OAS specification, and we could enforce that at the firewall. And if ever that API one were to give us something that is not in that contract, we would flag that, and we'd go straight back to that vendor and say, this API is out of spec. It's as simple as that, right? That you've bought a contract, you've bought a service against a contract. If that API stops doing that, something is broken and somebody needs to fix that. And of course, if you are a purveyor of APIs in a X corporation, what would you do? You would use 42 Crunch to go and assure your customers that you've taken every step to be producing secure APIs. And one of the artifacts you provide them is you would provide them an API definition that fully specifies your API contract, right? So if you're a consumer, use the firewall. If you're a provider, become a customer and be producing secured API definitions. So question 2, onto that topic of your upstream providers, your X corporation. How sure are you of your upstream API providers' security posture? Yeah, so nearly half of the people said no idea, which is exactly what I would have expected. And it's good. This is a worthy question to be asking, right? Is to say, what are you doing to secure your APIs? And I think it's a perfectly reasonable question to be asking as well. There's just a couple of other little housekeeping things. So we discussed the tweaks in terminology to just be a little bit more sort of broadly based and reflecting the changes in landscape. So further information, we'll get those links out in the slides. So we've got the Manico webinar. There's also Dana Epp. If you're not following Dana on his blog, go and do that now as well. Dana Epp, he talks about SSRF in a lot of detail. He talks about the changes. He's currently talking about great things you can do with Burp Suite. The OWASP is the main source, and as I said, go and read through the GitHub repos. It's interesting to go and have a look at some of their rationale and their thinking behind this. If you want to use the 42 Crunch extensions, it's possible to right through to being able to use our firewall, and you can go and get that installed. You go and register on our platform, you'll get limited access to our firewall, and the VS Code editor, which over 600,000 people are now using to be able to go and produce those fantastic API definitions that are fully specified and specify all of your data and its constraints. And finally, the API security.io newsletter. If you haven't already got that, or you're not already a subscriber, I'm working furiously to finish the last chapter or two on defending APIs. I was actually due to write the chapter on our very own firewall, which I'll be doing this week. That book should be out shortly. We have a couple of events coming up. API World is the big one in Santa Clara toward the end of October. Isabel Mane, our field CTO, will be presenting at that. She's also done a webinar with Tanya Janka from We Hack Purple that you might want to take a listen to. So the question is, are there any aspects you recommend someone who wants to start using automation? So I'm going to assume that's automation of API testing. So a couple of approaches here. So obviously, 42 Crunch does the security testing. So anything that we can do in the VS Code IDE where we can do auditing and we can do security testing. We can also do that in CI/CD. So anything there can be automated. So if you have an open API definition and you're building your API and you are wanting to test that, you can run those tests fully automated anywhere down your CI/CD pipeline. It's fast. It's not like a dynamic scan that takes hours to run. It'll run in seconds. So it's very well suited to CI/CD. It's suited to pull request flows. So that's if you want to use our product. If you're wanting to do more generic things. And funny, I asked this question on the last webinar about how many people are using Postman's Newman command line runner, and nobody said they were, which is odd because Newman is a really good way to automate API, your functional testing. Right, so those are the recommendations I'd make on that. There's a couple of other topics that allow people to do fuzzing testing or do basic conformance testing as well. So number of ways. I hope that's answered that. Yeah, depending on where you are, I go have a look at Newman, because that works. If you're using Postman, Newman follows into that nicely. Otherwise, 42 Crunch will do all of that. Anything you can do in the IDE, you can also do automated in the, and we've got integrations into pretty much all of the CI/CD systems that you'd want. And then the other question is, does 42 Crunch offer any security suggestions at API design beyond threat modeling? So I assume this, you mean activities that you would do at the time that you are doing API design. So I'd probably start with the data. I think about what does your data look like. Those think about your data models. So we first and foremost, we think about from the data point of view, because the value of an API, to an attacker is the data that it contains. So think about what your data looks like. You would then constrain that data using, we have a facility platform feature called data dictionaries, which allows you to provide a uniform definition of your data model across your organization. So things like, let's take an example, a vehicle ID number has a standard format, right? So define that across your organization. And that makes it really easy when you're doing your API designs to have a uniform implementation, so that you would say, all of my data conforms to this dictionary, to this data dictionary, and then that means that when you come to test that, or at runtime, everything is built in a uniform way. So that helps with security, because then it's much easier to go and detect when your APIs are leaking data that they shouldn't be leaking, because you can test against the standard definition. I mean, other things I do at design time, I would be considering implementing all the correct error codes that you would expect, removing unused methods. Those are things that I would consider doing at design time. Yeah, so authentication. So one of the problems, and I'm reading my chapter 2 on my book is all about authentication, and fully agree with that comment there that there's lots of guidance on how to do JWT, how to do cookies, how to do session tokens, etc. But there's not a lot of guidance on exactly when to use which one for which use case. And I absolutely agree with that comment. And that's something that we, as the thought leaders in the industry, we could do a much better job of that. Obviously, I can't give you a straight up answer to that. I tell you who does a good job of that is Philip Derek. He's got some really, really good free developer resources. He is really good at being quite prescriptive around which things are those, particularly if he talks about OAuth, which of the authorization flows to use. There's some, and the thing that's, I think, is frustrating to me as a practitioner is, and I'm, talking to myself here, is that these things are quite prescriptive. There's recipes. If you're doing a mobile device that is doing this, then there's a specific way you should do it. And there's best practice that says do it like this, don't do it like that. Do we offer solution API discovery and inventory? So we are working on that. We have up and coming a it's not available yet, but we have a solution to be able to do traffic analysis and discovery of inventory. What you can do is we can currently do, if your APIs are based on open API definitions and they are in your repos, we're able to go and introspect and access your repos and be able to identify API inventory that way. Right, I think that is it. So thanks again for the attendance. Good to see so many people on talking about this important topic. Thank you.